The Monty Hall problem is a famous problem based on the game show Let's Make a Deal. The host, Monty Hall, would have 3 doors. Behind one of the doors would be a prize like a new car, and behind 2 of the doors would be a prize like a goat. The assumption being that you would rather win the car than the goat. The contestant would first choose one door. Then Monty would open one of the unchosen doors to reveal one of the goats. The question is, what is the probability of winning the car if you switch doors? And what is the probability of winning the car if you do not switch doors? It is very easy to arrive at an incorrect answer, and many people will argue even after seeing the correct explanation. Here is the incorrect way of looking at it. Let's suppose you pick door number 1, and Monty reveals a goat behind door number 2. Then you might think there are 2 possibilities behind which the car could be, and you've chosen one of them, so the answer either way should be a probability of 1/2 of winning the car. We will now explain why this is incorrect reasoning. Let's take a look at a couple ways of explaining the correct way to look through this problem. Let's suppose that you start off by choosing door number 1. Then we should be able to agree that at this point there is a 1/3 probability of winning the car. There's 3 doors, you've picked one of them, so if they were all opened right now, you would have a 1/3 probability. Of the 3 outcomes, one of them has the car behind it, so that's a probability of 1/3. So if 1/3 of the probability says that the car exists right here, then that leaves 2/3 of the outcomes behind doors 2 and 3 together. So there's a 1/3 probability the car is behind this one door. There is a 2/3 probability that the car is behind one of these 2 doors. So when Monty opens the second door to show a goat, then there is still a 2/3 probability that it lies behind one of these 2 doors. But we know for sure it doesn't lie behind door number 2, so all of that 2/3 probability must lie behind door number 3. Therefore, it is to your advantage to switch from door number 1 to door number 3, giving you all of that 2/3 probability of picking the car, whereas there is still just the original 1/3 probability that the car is behind door number 1. Next, let's look at all possible outcomes. So the C represents car and the G represents goat. So the only possibilities are that the car can be behind door number 1, whereas the goats are behind door 2 and 3. Or that the car is behind door number 2 and goats in doors 1 and 3. And the last row represents the possibility that the car is behind door number 3 with the goats behind doors 1 and 2. Those are the only possible scenarios. So let's see what happens if we stay with our original pick and we don't switch to the unrevealed door after Monty has opened a door with a goat behind it. So if we choose door number 1 and the car is behind door number 1 and we do not switch, then of course we end up winning. If we choose door number 1, and the other 2 possibilities are that the car is behind door number 2 or door number 3, but not behind door number 1, then if we stay and we don't switch, then after he has opened the door, we end up losing. So of the 3 possible outcomes, we win one of those, meaning that the probability is 1/3 that we win if we do not switch. Now we look at the 3 possible scenarios where we do switch. So this time again, we'll pick door number 1, and the car is either behind door number 1, door number 2, or door number 3, with goats behind the other ones. Well, if we choose door number 1 and the car is behind door number 1, then when Monty opens door number 2 or 3, we'll just say 2 in this example, then if we switch to door number 3, then we're choosing one with a goat behind it, and we lose. But in the other 2 scenarios where the car is not behind door number 1, then when Monty opens a door, whichever the other door, the other unopened door, will have the car behind it. In this case, we've chosen door number 1 with a goat behind it, then Monty has to open door number 3 because he can't open door number 2 because that has the car behind it. So once he opens door number 3 and we switch, we'll end up picking the car at door number 2. Here, when we pick, in this scenario, with the goat behind door number 1, Monty is forced to open door number 2 because, again, he can't open door number 3 because that's where the car is. So Monty opens door number 2. If we switch, we end up picking the car behind door number 3. So of the 3 scenarios, we win 2 out of the 3 times, telling us that the probability of winning if we switch is 2/3.